Now we are going to do antiderivatives. So the way that I'm going to start this is I'm going to start with going back with what we know. How do you find the derivative of x cubed? So the derivative of x cubed is 3x squared. So what is the derivative of x cubed plus 7? Well, that's also 3x squared. What about x cubed minus 9? That's also 3x squared. This is called a family. It's a family of derivatives. All right, so what we're going to do now is I'm going to give you the derivative and you are going to have to tell me the function. Okay? And so we're going to start going the other way. All right? So the antiderivative is that I give you the function and you tell me the derivative. Now the reason that you're going to have to put for every single one of these for the next 2 sections, or actually maybe 3 sections, you're going to have to put the plus c. If you do not put the plus c, you will lose a point every time it is required and you don't put it. All right? So that's minus 1 point. So if you don't put it for 15 questions, that's 15 points right off the bat. The plus c tells me that, remember we talked about that this is a family. You don't know that it's not minus 9 plus 7 or 0. That plus c tells me that it's in that family. All right? Here are the basic rules. All right? If I have a constant, it's a constant. Now, the reason that we do that, I may have just lost everything. No, I didn't. There we go. Here's the one that we're going to be using the most out of all these rules. Okay. My iPad is not wanting to do nice right now. Is this rule right here. Is the power rule. It's tracking behind me. It's not tracking with me. Okay. Is the power rule. They make a big deal out of this, that if I integrate a constant, I get a constant times x. Well, think about the power rule. If I have x to the 0, so if I have a constant, x to the 0, that's really x to the 0 is 1, right? Well, then if I add 1 and use the power rule, then what that is that's the constant is x to the first over 1 plus c. If I think about a constant as x to the 0, then I'm still using this rule here, up here for the constant. Okay? So everything we use goes off of this. All right? It goes off of the power rule. This is the power rule. And it's the backwards of the power rule for integration, isn't it? If I have x to the n, then all I'm doing is I'm adding a 1 to it, and I'm dividing by that new addition. All right, so let's look at this example right down here. All right, the 4, again, is a tag-along. Just like 4 in derivatives, a constant out in front is a tag-along. Okay, so all you're going to do is you are going to have that tag-along. You add 1 to your exponent, so 7 plus 1 is 8, over your new exponent plus c. Now you do need to simplify this fraction. So your final answer will be x to the 8th over 2 plus c. That's it. You just add 1 to your exponent, divide by your new exponent, simple your fractions. That's all you do. It's not hard. You're going backwards. Okay? Here, what's my assumed exponent is x to the 0, right? So what is x to the 0? I add 1 to x to the 0, so I have x to the first. Divide by 1. It's over 1. That's it. So if I assume that this is the integral, of negative 6 x to the 0 dx, then when I get here, I have negative 6 x to the first over 1 plus c. That is simply negative 6 x plus c. That's all I'm saying. They make a big deal out of the integral of a constant is you put an x with it. Okay, the other way to think about this is that what when I take its derivative gives me a constant, a term that has a linear function. Okay, what when I take its derivative gives me a function that has a 7th degree polynomial, an 8th degree polynomial. That's what you're asking yourself. Okay? So, I have x to the negative 3 plus 1. So this becomes negative 2, right? Over negative 2 plus c. This right here is negative 2. That's why this is negative 2. So my final answer is x to the negative 2 over negative 2 plus c. Do you have to move that to the denominator and make it x squared? No, you don't. So this is the integral of 11x to the 1/3 dx. Do you have to write the dx if you rewrite this? Yes. The dx tells me what variable I'm integrating. Because I could have more than one variable in the integration, it tells me what variable I'm integrating. So I could have more than one variable. Okay. How do I do the 1/3? What is 1/3 plus 1? So that's 1/3 plus 3 over 3. So that's 4/3. So this is going to be 11x to the 4/3 over 4/3. 4/3. So how do I do 11 over 4/3? Well, that's 11 over 1 over 4/3. So that's 11 over 1 times 3 over 4. So that's 33/4. So plus c. So that's 33/4 x to the 4/3 plus c is your final answer. And yes, you do have to simplify the fraction. Okay, so here's your final answer here. And I don't want you moving your exponents. Okay? All right, now rewrite this. This is the integral of 4x to the negative 2 minus x to the negative 3 dx. Okay, so negative 2 plus 1 is negative 1, and negative 3 plus 1 is negative 2. So this is going to be 4x to the negative 1 over negative 1 minus x to the negative 2 over negative 2 plus c. So now I'm going to simplify the negative sign. So this is minus 4x to the negative 1 plus x to the negative 2 over 2 plus c. Okay, this is a typo. I'm not going to do it yet. Okay, let's look at this one. So this is the integral of 3.3 plus 5t to the negative 0.9 plus, and I'm going to rewrite this as 1/3 t to the 1.2 dt. So negative 0.9 plus 1 is 0.1. Okay, so this becomes 3.3t plus 5t to the 0.1 over 0.1 plus 1/3 t to the 2.2 over 2.2. Now I'm going to put that in parentheses, plus c. So this equals 3.3t plus 50t to the 0.1 plus t to the 2.2 over 6.6 plus c. How did I get 50? Well, this is 1.1 is 1 over 10. That's in the bottom, so that flips, so it's really 10 times 5. And 1/3 times 2.2, 3 times 2.2 is 6.6. So this is my final answer. Okay, here is a typo. This should be squared. You don't know how to do it if it's not, at least not yet. So this needs to be, you're going to have to rewrite this. This is the integral of 3x squared over x squared minus 7x squared over x squared dx. So this is the integral of 3 minus 7x to the negative 2 dx. So that equals, so we have negative 2 plus 1 is negative 1. So this is 3 7x to the negative 1 over negative 1, which makes this a plus c. Right, because this would be over negative 1. That was a minus sign, so that changes both of those to a positive sign. And that would be your answer. Okay? And then we have one more example that is a word problem, because we always have a word problem. Now, this word problem is a little different. Things you need to realize that your function, your f of x, is your distance. Your derivative is your velocity. And your second derivative is acceleration. All right? So if I tell you that, so if I tell you acceleration due to gravity equals 32 feet per second squared, then, and I give you this information, then you know that your v of t, so this is typically written as s of t, this is typically written as v of t, and this is typically written as a of t. That v of t equals 8, because your velocity upward is 8, minus 32t. Okay? So if I then, since the derivative is distance, since the derivative of distance is velocity, then the integral of the velocity is the distance. So if I integrate, so s of t now equals the integral of v of t dt. So that tells me that if I integrate 8 minus 32t dt, that I will get my distance function. So that gives me 8t minus 32t squared over 2 plus c, which is 8t minus 16t squared plus c. Since I know that the height at this means right here that the height at 0, okay, so this could also be h of t, or I used s. So this means that s of 0 equals 185. That if I'm at 0 seconds, that when I toss this weight upward, that I'm starting at 185 feet. That's what this means. All right. So that tells me that C equals 185. Because S of 0 is 185. All right. So this could also, I called it D in my notes. So that tells me that S of t equals I'm going to do this differently, minus 16t squared plus 8t plus 185. All right? So that is the distance. This is the distance that the weight travels. This is the distance function. Okay? So knowing that, what the last part is asking is to maximize that function. So this peak equals the word zenith. The zenith is the peak. Means that the velocity is 0. So that means that I want to find where 0 equals 8 minus 32t. So that means that 32t equals 8. So t equals 8 over 32, which is 1/4 a second. So now what I want to find is I want to find s of 1/4. So that's 8 times 1/4 minus 16 times 1/4 squared plus 185. So that's going to equal 2 minus 1 plus 185 equals 186 feet. So the zenith of this rock, or the peak of the rock, will be at 186 feet. Okay? So that shows you, so what's the point of all this? So what is the point of all this? So say that you're given, so what I've done is I've taken a function, I've written the function, I found the original function, I've then taken the derivative of that original function and found where I can maximize it. Okay? So I've used everything that we have done thus far in this course. All right? So please, please, please email me if you have any questions whatsoever. Okay? Thank you.